Let's first look at the graph of that function and say some things about its first and second derivatives. Now, the first derivative is basically the slope of tangent lines to the graph of that function. So let's include a few of those tangent lines and let's make some comments about the way that they behave. First of all, let's recall that wherever we've got a local minimum or a local maximum, those tangent lines are horizontal, and that tells us that the first derivative at that point is 0. So this happens at these places. Let's make a table where we indicate the sign of the first derivative. And so precisely at these places, the first derivative is 0. Now what about between those places? Well, here the slope is negative, here the slope is positive. The slope first increases and then decreases back so that it becomes 0 when we get to this point, and then the slope becomes negative once more through this point, whereupon it increases one more time and becomes positive. Now you'll observe that the transition between a negative to a positive slope means that as we march in the positive x direction, the first derivative is increasing. On the other hand, if we look at this range from positive to negative, now the first derivative decreases. Over this range, the first derivative increases once more. We can summarize this behavior by saying something about the sign of the second derivative. The second derivative tells us about whether the first derivative increases or decreases. So the sign of the second derivative will be positive here, negative here, and positive here once more. Now, in order to change between positive and negative, there should be some point here in the middle where the second derivative becomes 0. And the same is true here. In going from negative to positive, the second derivative should be 0 one more time. Now, we can identify those points on the graph as being so-called inflection points. The key property of such points is the fact that the second derivative changes sign locally. That signals changes in concavity of the graph from areas where it is concave up, for instance, over this region, to areas where it is concave down. And similarly, here again, it is concave up.